Welcome to the channel where all you gotta do is science out the pedal assembly. So this here is pedal assembly I bought a couple weeks ago, whatever. So brake pedal, clutch pedal. These are master cylinders. I stole these from the Bronco project. These are 3/4 inch, no, 5/8 of an inch, sorry. Piston diameter. This is for the Bronco, so I already scienced out what diameter I need for the Bronco, but this program I have not. And then I need to mount this. It's going to mount to the A hoop, which is my previous video. Anyway, I'm not a real big fan of Willwood products. They were in the Ventura area, and I knew a lot of people, probably I don't know, 8 or 10 people that worked there, and they all had the same evaluation. They copy AP Brembo stuff and cheapen it up and then sell it like it's theirs. So I'm not a big fan, but since I bought this used, I'm not really giving them my business. I can justify it in my head. So anyway, I think this will work really well for me. It's fairly light. Which I got to keep this thing under 3,000 pounds, so that's important to me. But I also wanted to go over a little bit about how I'm going to mount it and how the bias bar works, because there seems to be some confusion on the old interwebs on what actually is happening. So basically what you have is you have a master cylinder here, and there's a piston in there, and a master cylinder here, a piston in there. And then the pressure goes to the rear brake and front brake. So what you have here is basically a pivot system. And the pedal is pushing on this fulcrum here. And these brake cylinders only come in like, you know, kind of fractional sizes, 5/8, 11/16, 3/4, 1 inch, 1 1/8. So you can't get the balance perfectly right, no matter what you do. So you have to have a bias bar in there, or some sort of proportioning valve or ABS or something to make the front and back balanced. So the way this system works is this is basically on a threaded rod, and you try to size the diameter of this one and the diameter of this one based on what calipers you have and what size tires, wheels, CG, amount of grip, you know, a bunch of stuff goes into it, which I'll go into a little later, what my spreadsheet looks like. But basically, if you twist this little knob, it moves the fulcrum point. And then there's been some confusion or some misrepresentation of how it works on the internet, that basically it applies force to the rear brake first, and that's what this adjusts. That's complete. That is not how it works. Basically what you're doing is you're supplying pressure to the rear and pressure to the front. And this seesaw, essentially, it's like a kid in the schoolyard, and there's a seesaw here, and there's a fat kid over here and a skinny kid over here, and no matter what happens, this fat kid's always going to hit the ground first. So basically what this does is it moves the fulcrum point over. So mass times radius on this is the same as mass times radius on this. So then it balances out. So essentially that's what you're doing. You're moving the fulcrum point from your seesaw to a position where the radius gets bigger on one side and smaller on the other to compensate for how much force you need to be balanced during threshold braking. Now, of course, that's challenging because if your grip level changes, then your threshold braking front to rear is going to change, your CG is going to change, right? But that's why these typically have adjustment knobs on it. My plan is to make the adjustment knob where the key goes into the, normally goes into the ignition on this. So it'll be nice right there. You can see that this And when you push the pedal, those guys go in and out. There we go. So they're going kind of even now. Now if I twist this thing one way, so you can see this one's going more because it has more force on it. And if I twist this way, you can't do this all in one corner. You have to do it like one corner at a time. See, now this one's got more force on it. So that's how this works. It isn't anything about putting pressure to the rear tires before the front tires. Like nothing happens until both of these have pressure on them, right? Like if one of these, which is kind of a problem, can be a problem. If one of these lines breaks, then you basically got nothing, right? Like if you just disconnect this, like you push the brake in, you got nothing. It's like an old-timey car that only has one master cylinder and one circuit. If you lose anything, you're shit out of luck. So very important that this stays connected and you don't have any brake line failures. So anyway, that's the 101. And then this is just the clutch, right? The same similar cylinder goes over here for the clutch. Of course, there's calculations on that too. You have to know how much throw you need at the clutch and what size the slave cylinder is, and then you can choose the. You probably can't call it a master cylinder anymore, but so they used to be called in the olden days. I just kind of mocked up that unwelded in roll hoop and figured out where it fits. And here's my CAD drawing of it. So I'm just gonna bandsaw off some pieces of material and then bend them and then machine them. And the reason I'm doing that is because if you machine this part like that, flat piece of metal with the roll hoop diameter on it, that's the bend line and a couple of holes. So if I make this piece or get it laser cut or water jet or whatever, and then I bend it, if I don't get that bend exactly in the right spot, then everything's foobar. So instead what I'm going to do is make this a little bit bigger and this a little bit bigger, and then I will put it in my, well, press brake. It's really a Harbor Freight 12-ton press with a old junky vise on it and some cobbled up fixtures that I made. Anyway, I will bend this fairly close, within, 1/16 of an inch. And then I'll put it on my milling machine. If you don't have a milling machine, you could just, use your hand grinder, scribe some lines on it and match those. But I'm just going to put it in my, make it an angle, put the angle in my vise, and then trim the edges up, and then square it all, and make it so it's, like this. So, in actuality, I've already done that. I already cut it out and bent it. And then I put this in my milling machine. I held it on this surface, like that, in the vise. And I trimmed this side up and this side up. Did that to both of them, made them 4 inches. And then I put them in the vise this way and trimmed this up and this up. Now these are both the same size and all perpendicular and happy. So now what I'm going to do is I'm going to put them back in the milling machine like that, and I'm going to make them touch each other, and then I'm going to drill a 1/4 inch hole right here, and then go through my hole saw, which is 1 5/8 inches, and then I'll have the half hole in each one. Right? If I try to drill a half hole in this, it's not going to come up round. So that's my cheat on that. And then I'll come back and I could put these holes in any time, but I'm gonna do that first, and then I'll fixture it on the mill and put the holes here and here, 3 inches apart, which is what that is. So anyway, that's my plan, and then I'll get it mocked up on the A-hoop, which is in there. Okay, so I got this thing all mocked up. I don't know how well you can see it, but there it is. Looks like it's going to be a giant pain in the ass to install it. But it's okay as long as it's possible. I put these the center of the pedal, about 8.5 inches from the floor. There's going to be like carpet padding and carpet on there and the rest of the floor, so that'll end up being like around 8 inches, which is about what I wanted. So anyway, looks like the master cylinders have tons of room, the clutch cylinder has tons of room, everything is fairly tidy. All my steering column goes right between the pedals. So I think this is gonna work out fine and dandy. I don't think I'm getting into any, I mean, there's probably stuff there that the original 68 Mustang had, but I won't be using any of that. Okay, so I didn't like what I had. It's pretty normal for me. So what I did was I flipped those brackets upside down. If you can see here, but not really upside down, but these brackets used to be on top. Used to come like that and go on top, and that was going to be a bit of a pain to assemble, so I cut 600 thousandths off of this and moved this still to the center line, and then now it bolts to the top. So I'll weld these nuts to the bottom side so I don't have to fiddle futz around with it. My only challenge is getting this bolt and this bolt in there, but I think I got enough room. Let's try it in real time and see how bad that could be. We'll edit in post if it doesn't work. Yeah, so that's close, but that's gonna work. And then I can slide it in from this direction, and yeah, so I'll get that guy tacked in there. But I think this is the ticket, and it isn't adding much weight, right? So this crossbar is already there. All I'm adding for weight is these little brackets here. Okay, so this is the spreadsheet I put together for figuring out what my master cylinder sizes need to be. So we'll start from the top here, and you need to know the weight of the vehicle. This is the percent rear. That's where it is right now. It may change, but and this is the length of the pedal assembly, and it gives you the lever ratio, which this one is advertised as 6.25. So I measured this with the yo-yo and came up with those approximate numbers. Pedal force, that's an input. All these boxes are inputs. The ones that are shaded is calculation. So I put a 120 pounds in for the pedal force. You can make that whatever you want. You just have to have different size cylinders to account for it, but typical human, 200 pounds is not a problem. This bias bar ratio, that's 50-50. If you change one to 70, the other one will turn into 30. And then you got your master cylinder diameter. I have 5/8 right now, but we can change that. And then all these are based on your caliper. So these are the F10 BMW M3 cylinders. So I took them apart and measured them. That's what they are. It's pretty close to what the internet says, but not exact. The reason these are all different numbers is because there's a moment where the reaction point on the pad versus the thickness of the pad, it puts a moment on the brake pad. So you get a different amount of force on the leading side of the pad versus the trailing side of the pad. So that's those different sizes are to compensate. Now the Mustang is just a base model Mustang, and they're the same front and rear. It's cheaper that way. You can just make the same caliper and just put the outlet in a different spot. So kind of cheesy, but it's built to a cup price point. So that's what you get. These are all calculations of the area from the previous inputs. And then this is pad mu. You can get stickier pads or cheesier pads. Tire diameter. It could be different front and rear. And then this is the rotor OD and the rotor ID. Those are the surfaces of the pad. So that's used to calculate the active radius. And then with all those inputs, you can figure out the pressure and figure out the wheel torque, which is basically just the radius times the radius of the wheel and how much ground force you have. So pretty simple calculations. The output of this is this deceleration. It's like this one's 0.93 Gs and this one's 1.3. So we're a little bit mismatched there. So we can go back and change a bunch of stuff. We can change the bias ratio, bias bar ratio, or we can change the master cylinder ratios to get those more even. That's really the outcome that we're looking for, is the deceleration. So if we go up in here and change the master cylinder to 3/4 of an inch, 0.75, and we can see that changed pretty close now, right? We're at 0.93 and 0.9 Gs, so that's pretty close. We can compensate with the bias bar ratio there because they're not too far off. We'll change that to 49%, and then yeah, those are really close now. So 92.91 Gs, so that's good. So down here, this is just the lock pedal force. This is really crude. It doesn't really tell you anything. It just uses tire grip and the area ratio. It doesn't look at the bias bar. It doesn't look at the weight distribution of the car. It's just kind of to get you in the ballpark. So, and then the bottom, the pedal throw and stuff, that's just a calculation of the area, the hydraulic area, pedal ratio. So pretty simple calculations down here. This is like the first stuff. The yellow stuff is the first stuff you should look at just to get you close. And then you can kind of fine tune it with your percent weight in the rear and bias bar ratio and all that junk. Thanks for watching. If you like this content and want more, subscribe, like, and share.